Hi Year 12, welcome back to class. Hope it wasn't too hard to find this video clip. This week I'm going to be away with the musical, so I thought what I'd do is I'd record each of the lessons for you so you can actually get the value of me being, at least hearing my voice again. Some of you might not like that part, but never mind. So today I want you to watch this one in class, and then tonight I want you to watch the next one so that you're ready for class tomorrow. And I will be checking, see how many views we're getting, just to make sure everyone's watching it. And if you've got any questions, just post them on underneath each of the videos, and I'll try and get to them. But with the musical, that might be a bit tricky this week. Okay, what is expected? Whilst watching each of the video clips, I want you to copy down the notes. You can obviously pause and rewind whenever you need to. So either pause while you're writing down the notes and then play again to listen to the explanation. Also, when I do examples, you can pause, have a go at the example yourself, and then play again just to see if you've got it right. When I come back in on Monday, I will be checking to make sure that you've all done that. Okay, this week we're looking at geometry of the Earth, which is a new topic, and we haven't really touched on this before. You would have done a little bit on time back in Year 7, but other than that, we haven't really done it at all. So we're looking at the Earth and some of the key aspects of that. It's not a particularly big topic. We've only got 4 or 5 lessons on this, which is why I'm doing these recordings. So geometry of the Earth. Today we're going to look at longitude and latitude, and we'll continue that tomorrow. There's a few different parts of that. Then we'll look at how to calculate the distance between cities, so the length of an arc, which we have actually done before. And then later on in the week we'll look at longitude and time differences. Okay, now you need to start taking down the notes. I don't expect you to draw all the pictures. I'm getting most of them from the textbook this week just to make it easier. But it would be a good idea to sketch out a few of them with key information. I'll give you a hint as to what I want you to draw down as we go. So, longitude and latitude. Positions on the Earth are described by coordinate systems involving latitude and longitude. So you know when we're looking at graphs, we say the coordinate, 1, 2, and we know what that point means. Well, we use longitude and latitude to describe different points around the Earth. So there's special grid lines that run across and down the Earth, or around the sphere, or down the sphere. And you can see we've got 2 examples down the bottom here, one that's obviously the sphere of the Earth, and then one that's sort of a flat picture of it. Now, some of you probably from geography would know that the longitude lines sometimes are a little bit sort of change direction a little bit, but we'll get on to that later. Okay, just a few key things before we start. We use sometimes great circles and small circles as referred to in this topic. A great circle is a slice through the centre of the sphere, and its radius is the same as the sphere, so the distance between the centre and the outside is the same, obviously, for the circle and a sphere. And the equator is an example of a great circle. Obviously, it's a slice straight through the middle of the Earth. And then we have small circles, and they slice through a small part of the sphere, and obviously their radius is small. That's not a big piece of information for you guys. Okay, let's have a look at parallels of latitude. They're imaginary parallel lines that run around the Earth. So latitude is going around the Earth. The largest is the equator, which is sitting here in the middle. I'm just trying to get my pen to draw. Okay, we've got the equator. Oops, sorry. And that's at 0 degrees. Above the equator is the northern hemisphere, and below is the southern hemisphere, with the North Pole at 90 degrees and the South Pole at 90 degrees south. So what I want you to do here is draw a circle, put in the equator with 0, the dotted lines, North Pole, South Pole with their bearings. I'll just erase those so then you can actually copy it down. Again, whenever you need to, pause, stop, rewind. Alright, next slide. Oops, sorry. Angles of latitude. We need to be able to calculate or find the angles between the different latitudes. So we start in the middle of the Earth, okay, draw a line out to the equator, and then we measure our degrees up to get, in this case, 50 degrees north of the equator. Again, if we wanted to do something to the south, so from the middle out to the equator, 35 degrees down, this one here is 35 degrees, oh, that was bad, 35 degrees south of the equator. And that's how we calculate that part. Okay, let's keep going. Okay. With the latitude, there's just a few simple ways of remembering it, because a lot of people do struggle to remember the difference between latitude and longitude. So A is for across, we're going across the Earth, and this is latitude. A is the second letter in latitude, and then we've got lat is fat, or lat is flat. That's, I think that one's the best one for me when I'm remembering. Remember, when we're looking at latitude, we're looking at the north and south. So whenever we're saying latitude, it's always north or south. And these ones here, obviously, they're small circles. These rings here, with latitude, the equator being a large, big, great circle. Okay, let's keep going. Okay, meridians of longitude. When we're referring to the lines of longitude, we call them meridians, so just be aware of that. They're imaginary semicircles that run down the Earth from north through down to south. Okay, the main one that you need to know about is the prime meridian, or the Greenwich meridian. There's quite a few names, but I'll call it prime meridian. And that runs through at 0, 0. So in this diagram, it's this one, and it does change in different diagrams, so make sure you look for that little bit there. The international dateline is directly on the other side of the Earth from it, and we can say that as 108 degrees either west or east of that. So from here, from the prime meridian around to the international dateline, that's the eastern hemisphere, and this way around is the western hemisphere. Each of these lines is, so this one here is 15 degrees east, this line here is 15 degrees east of the prime meridian. This one here is 30 degrees west of the prime meridian. Okay, erase. I think that's all for this. Sorry guys, I'm still learning this. Angles of longitude. The angle the meridian makes with the prime meridian at the center. So this is our prime meridian here, going down. Okay, that's at 0. And then from there we're going 30 degrees across. And so this one here is 35 degrees east of the prime meridian. And that's how we calculate angles of longitude, or that's what that will look like. Now, often the prime meridian will be off to the side, so don't get confused by this one in the middle here. That's sort of like the center of the cut. Erase. Change. And for longitude, if you have any problems, lines are long. They're long lines down the shape. O for orange or onion, longitude, the second letter is O. That might be a handy hint for you. We've got hoops, they're all big great circles. And when we're looking at longitude, we're looking at east and west. Okay, position coordinates, this is the important part for today. Locations on the Earth are described by using latitude, north or south, and longitude, east or west. We always say latitude and then longitude. So we say if we're going up and down, and then we say if we're going side to side. So for example, if I say 35 degrees south, 149 degrees east, I mean 35 degrees south of the equator and 149 degrees east of the prime meridian. Let's have a quick look. This is an example from your textbook, so you can have a look there if you want to. Okay, match the following coordinates to the points illustrated. So we're at 55 degrees south, 55 degrees east. So let's do south first. So 55 degrees south, that's this line along here. And then 55 degrees east. So out here along this line, so it must be W. I'm pretty sure that's, yep, W. Oh dear. W. Okay, B, 30 degrees north, 55 degrees east. So we want to go 30 degrees north, so we're on this line here, and then we're going 55 degrees east. That's this way, so must be S. Again, guys, if you want to, make sure you pause it and have a go yourself, and then watch me finish this off if you want to. Okay, 75 degrees north, that's right up here on this top circle. 0 degrees east, so that must be P here. Remember, this is our prime meridian, as you can possibly see from your from the example. So we're looking at P. 0, 0, so this is the equator coming through here. And this is our prime meridian, so it must be T. 0 degrees north, so again we're on our equator. 55 degrees east here. This point here. Oh, what did I do then? Oh, zoom out. Okay, sorry, accidentally zoomed in there. So E, we've got 0 degrees along the equator and 55 degrees east, so it must be U. And then 75 degrees north, so up here 55 degrees east, so that must be Q. Okay. There's a variety of different types of questions. There's one that's exactly the same as this. Question 1 is exactly the same. Question 2 and 3 are variations of that, so they give you the points and you have to match them up. Okay, lucky last. So, okay. So in class today, exercise 901, page 390, questions 1, 2, and 3. And then tonight for homework, can you please watch the clip on calculating the difference in longitude and latitude, write down the key notes, and then tomorrow in class you'll be able to go through any of those questions. Alright guys, make sure you post if you have any questions, and I'll try and get back to you. See ya!